Hi everyone. Today we will be discussing about our findings regarding TOK natural sciences in the area knowledge of natural sciences. Let's move on to the real life example. Our real life example is the anti-vax movement, which was a significant phenomenon during the height of the COVID-19 era. One of the main heroes of the anti-vax movement was Michael Yeadon or Yeadon. He was a former Pfizer vice president, I believe, and he, for some reason, has vocal opposition against the COVID-19 vaccines. In June of 2021, he has made a very controversial statement regarding the vaccine. Okay, what is his claim? Basically, he claimed that children are 50 times more likely to be killed by the COVID vaccines than the virus itself. Let's move on to step.
Moving on to the certainty of the claim. Since we are not biased, it can be uncertain or certain. So we want to look at the claim. For the certainty of his scientific data, he has not published any data or studies in reputable scientific journals to substantiate his claim. So that means he does not have strong evidence and he also not don't have. Tapi dia ada PhD in medication.
It's like when you hear someone talk, kan, basically like, yeah, it's a talk, but from who? This guy has like a PhD, but like doesn't really make sense, kan? Like it doesn't really make sense, but like this guy has a PhD in pharmacology, so like, are you legit? Are you not legit? That's like the issue.
So that means he is somebody lah. So if he whatever he says, people like concerning his certainty because he has background in education, bachelor science degree in biochemistry.
Minutes, louder please.
Louder and clear.
And toxicology and a PhD in pharmacology from the University of Surrey. Okay. And the justification for his claim, he just referred data from the vaccine evidence event reporting system called DAERS, accept reports from anyone, including healthcare providers, patients, and family members. This openness is important for capturing as many potential adverse events as possible, but also means that report can include unverified, incomplete, or inaccurate information. And tak reliable sangat.
So we move on to the knowledge questions. Where how do we determine the reliability of scientific evidence? So we unpack the knowledge question, the knowledge question into determine reliability and scientific evidence. So first we move on to the determine. What is determine? So to establish or conclude something based on evidence and reasoning, or it is a process of evaluating whether scientific knowledge is trustworthy and valid. And what is reliability? So it refers to the extent to which knowledge or data is consistent, dependable, and can be trusted over time. So reliable knowledge is that which consistently produce the same result under the same condition and is corroborated by repeated observations, tests, or experience. So, lastly, the scientific evidence. So, scientific means related to or based on science, which is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and prediction about the universe. So, what is the evidence? Evidence is information or data that support or refutes a belief, hypothesis or theory. So scientific evidence is important for understanding how knowledge is constructed, validated and communicated in the natural science.
Alright, in this slide, we will be raising some key questions related to our knowledge question, which focuses on the reliability of evidence in scientific methods. Let's go through each questions one by one and explore its significance. For the first question, how do scientific methods ensure the reliability of evidence? Scientific methods are designed to systematically and objectively gather data. They include steps such as hypothesis, formulation, experimentations, and analysis. By adhering to these structured steps, scientists can minimize bias and errors, thereby ensuring that the evidence collected is reliable. For the second question, what role does peer review play in establishing reliability? Peer review is a critical process in the scientific community, which scientists submit their research for publication. It is reviewed by other experts in the field. This process helps to identify any flaws or biases in research, ensuring that only high-quality, reliable studies are published. Peer review acts as a filter to enhance the credibility of scientific findings. For the third question, can scientific evidence be considered reliable if it is not replicable? Replicability is a cornerstone of scientific reliability. If a study results can be consistently reproduced by other researchers using the same method, it reinforces the validity of the finding. Conversely, if the results are not replicable, it raises questions about the reliability of the original study. Therefore, replicability is essential for the acceptance and reliability of scientific evidence. For the fourth and last question, does educational background alone justify the certainty of the claim? While a strong educational background can lend credibility to a researcher, it is not sufficient on its own to justify the certainty of a claim. Scientific claim must be supported by empirical evidence and rigorous testing. The reliability of a claim depends more on the quality of the evidence and the methodology used rather than the educational background of the individual making the claim. So in summary, these questions help us delve deeper into the understanding what makes scientific evidence reliable. By addressing these points, we can better appreciate the process and criteria to ensure the credibility of trustworthiness of scientific knowledge. Thank you for listening. That's all.
Okay, now continue to the step 4, which is underlying or identifying or analyzing the assumption. So in this part, they are consist of 4 things. First is the reliability in science established through rigorous testing and validation. The second one is the peer review and replication are essential for verifying scientific claims. And the third one is reflect on potential biases. So as we learned before with Ms. Iza about the potential bias, so we're gonna evaluate some of the potential biases that might influence the claim. This could be personal and cultural biases. And then lastly, we're gonna evaluate the claim from different viewpoints to reveal hidden assumptions. Okay, that's all.